What I have here is a board with a nail in it. You can see the nail. That's going to act as my third hand. I also have a string that has 12 knots in it. So if I start with this one, count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have these 3 knots marked with a black ink so that I can see what the spacing is to form a right triangle. When I made this string, I didn't get out a ruler and decide on a particular measure and be very careful in measuring everything perfectly. I just took something in my house and said, the knots are going to be that far apart. And then as I was tying the knots, I just aimed to have them about that far apart each time. And of course, the last knot was the most challenging to put in because it had to be that far apart from both sides. But it wasn't particularly challenging to do. Since you don't have to have a specific measurement, you just have to have a standard. And I used an eraser, an old eraser I had sitting around, and it made a really nice width for my knots. So I don't know if you measured it in inches or centimeters, what the measurement would be. I haven't checked it. So I tied my 12 knots, and then I set up the knots so that there are 1, 2, 3, 4, 5 between 2 of the colored knots, 1, 2, 3 between the next 2, and 1, 2, 3, 4 between the second and going back to the third or the first, if you however you want to call that. So what I've got myself set up to do is to make a 3, 4, 5 triangle. And this is something that we know that the Egyptians knew of and used to help for construction. And here's how we can show it. If I use that nail as my third hand, and I put one of the black knots over the nail, and I put my hands on the other 2 knots, I can pull, and you can see that there's a right angle by my left hand. Now, it might not be perfect, but it's a lot better than just trying to guess. And you could use this to check if a board or a stone wall or whatever you're working with is a right angle. It's going to be awfully close, and the better or the more precision you take in spacing the knots, the better, the closer to a right angle this will be. And what's fun is sliding this around a little bit. If I slide it like this, and I put my hand there, if I put my fingers on these knots and the nail on that other knot, I just made an equilateral triangle. If I did it like this, let's see if I can play with that a little bit. Well, there's a right triangle again, just not with my hands on the knots the way that it is. But you can make a variety of triangles this way. You can make, there's an isosceles triangle. It's kind of a fun thing to do, and it's just as easy as pounding a nail into the board, or if you have 3 people, 3 hands available, then you can do this. It's a great little demonstration for kids, and you could have them go out and measure things. They could look at painted lines on the ground. They could look at sidewalk joints where the concrete comes together and they're marked off at right angles. You could have them tuck it into the corner of a wall and see if they can get a right angle. You can have them put it over a table and or a desk that doesn't have rounded corners but has, or even if it does, you might not see the angle exactly, but you would see that the sides would be parallel to the string that you're using here. What a great tool, and what a great inexpensive thing to do for your classroom, to have kids be able to see that they're making a right triangle, and all it takes is string with neatly spaced knots. And of course, you can make strings with other knots. You can take any Pythagorean triple and make that many knots, the sum of the lengths of the sides, that many knots, and you can have them make other sized right triangles.